Okay, so this is Unit 3, Radical Functions. So now we're studying radicals. Last unit was absolute value, now it's radicals. Today we're going to be doing 3A, which is converting from radical notation to exponential notation and back and forth and vice versa. And B, simplifying radical expressions containing rational numbers and variables. So let's get into it. 3A, so here we're just converting. So right now this is in radical form. You see a radical here, you see a root, that's a radical. And we need to change this to an exponential form. It's pretty simple. The exponent, this becomes your numerator. The radical, the root, it's called, is your denominator. So how we write this is what's underneath the radical, put that in parentheses, and you raise it to the exponent of, since it's exponential, you're going to have an exponent of 7 over 4. I guess technically you don't have to have the 2 in parentheses, but it's not a bad habit to have. Either one's okay. Example 2. We have, oh, now it's 7 over 4 again. So the P is the only thing that's in the radical. The 5 is on the outside. The 5 has nothing to do with the radical at all. So it's just 5 times. And then it's going to be P raised to the 7 fourths. So again, this becomes your numerator. This becomes your denominator. So we can just rewrite this about the multiplication into 5p to the 7 fourths. Example 3. So now I see the radicals in the denominator. We're going to keep it in the denominator. So we're going to solve this problem as it's 5r that is being raised to, there's no exponent, so it's really to the first power. So we have 5r being raised to the 1 is going to be your exponent, or your numerator, and the 3 is your denominator. So 5r to the 1/3, so 1 over that. So if you notice here, the 5 is included in the radical. Next. So now we're going to go back the other way. So this is exponential form, and we got to change it to radical form. So let's change this exponent to radical form. So the numerator becomes your exponent. Your denominator becomes your root or radical. Either one. So we have on the square root, it's a cube root from here to 3. Cube root of 5 to the, no, 6 to 6. 6 to the 5th power. On here, number 5. The only thing here is 10 times a to the 7 fourths. So only a is being raised to the 7 fourths. So here we're going to have 10 times the radical. The 4 is your denominator, and the 7 is your numerator. So we can rewrite this 10 fourth root raised to the 7. We can have another example. If I had it like this, then the 10 is included with the 4th root. So it would be 10a, put it in parentheses, raise it to the 7th power. So that's from exponential to radical form. Moving on, now we're going to simplify radical expressions. So simplifying radical expressions, you already know, like, square root of 4 is 2, square root of 9, 3, square root of 16, 4, so on. Keeps going. There's a couple different ways you can do this. I'm going to teach a tree method. A lot of you probably learned that in Algebra 1. But be like, if I had the square root of 25, you can break it down into 5 times 5. And if you have a pair of 5s, it's the square root of a pair of 5s, so you're going to bring it out as a 5. So 72, I'm going to do the same thing here. Yeah. What times what is 72? We're just going to do 36 and 2. 36 is 18 and 2. 9 and 2. 3 and 3. I always circle my prime numbers. You don't have to. Usually keeps things a little straighter. This is a square root 2, so I need pairs of 2. So I have a pair of 3s. What you do, every time you have a pair, you write it once. I have a pair of 2s. It doesn't matter which pair you circle, and it's going to be multiplied. And I have another 2, just this 2 here doesn't have a pair. So what happens is it stays underneath the radical. So my final answer is 3 times 2 is 6, square root of 2. Now with a variable, we're going to do this the same way. So 98, break it down into 49 and 2. 49 is 7 times 7. Those are prime numbers. Now the x to the 7th. Break that down, it's just x times x times x times x times x times x times x. So 7 x's. Square root, so I need pairs, so there's a pair of 7s. Comes out as 1 7. There's a 2 left over, so that's going to be underneath the radical. Now with the variables, you have a pair of x's, another pair of x's, another pair of x's. So that's x to the 3rd. 3 x's. There's an x left over, so 2 times x stays underneath. So we have 7x to the 3rd, square root of 2x. That is simplified. Let's try this one. 32. We have 6 times the square root of 32x to the 10. 32 is 16 times 2. 2 times 8. 2 times 4. And there's other ways you could have broke this down, but in the end you're going to have 4 2s or 5 2s. And so we have a pair of 2s, doesn't matter which pair you circle. Another pair of 2s. So you multiply every time you have a pair. And, oh, I forgot the 6. So there should be a 6 on the outside here. So 6 from here. And then a 2 times a 2. And then x to the 10. How many pairs of 10 can you get out of? Or how many pairs can you get out of 10? And you should be telling yourself 5. X to the 5th. And then square root, what's left over? All the x's got used up because there's 5 pairs of them. We need pairs squared. And the only thing that's left over is a 2 that will stay underneath. So 6 times 2 is 12, times 2 is 24. X to the 5th, square root of 2. Doesn't look more simple, but it is. And next one, cube root of 320. So we break it down the exact same way. So 160 times 2, 16 times 10, 8 times 2, 4 times 2, 2 times 2. Again, it doesn't matter how you break this down, you're going to get the same numbers in the end. So we have, now it's a cube root, so we're looking for 3 of a kind. So I have 3 2s. Oh, just kidding, 2. So there's 3 2s, so I write 1. I have 3 more 2s. So I'm going to write another 2. There's a 5 left over. So that goes underneath. So this 5 goes here, 2 from this, 2 from here. Rewrite it. 2 times 2 is 4, square root of 5. Just kidding. Cube root. Cube root. Don't forget that cube root. Very important. And the last problem for the day. 250. Break it down the same way. 5 times 25. 5 times 5. H to the 12th. So we have, you can break the H's down. You can write down 12 H's if you want. It's not needed. There's 3 5s because it's a cube root. So 5 comes out. H's, how many groups of 3 can you get out of 12? Should be saying 4, so change to the 4th. Cube root of 2 is left over. That's your final answer. Just for 10 minutes. So a couple questions. Come to class with any questions. Hopefully it makes sense. If not, I'll explain it in class. Thank you.